Is Earth being watched by something not of this world? A Harvard scientist reignites debate by suggesting that an approaching interstellar object may not be a harmless comet, but an alien reconnaissance probe.
Astronomers have just confirmed a mysterious, colossal object from another star is hurtling towards our solar system at 152,000 miles per hour.
A chilling prediction of an alien mothership heading for Earth and when it could arrive. Could first contact be closer than we think? The interstellar object or the alien ship traveling towards the inner solar system will reach Earth and put its plan into action between November 21st and December 5th, 2025.
For the third time in history, scientists have detected an interstellar visitor. And this one might be the biggest, fastest, and most mysterious we've ever seen.
A shadow of profound cosmic intrigue now falls across our planet as a mysterious object hurtles through our solar system.
And here's where it gets even stranger. Late June 2025, the Atlas survey in Hawaii catches a faint, slow-moving dot during its routine night sweep of the sky. At first glance, it's just another speck drifting through the darkness. Nothing unusual, no buzz, no breaking news. Astronomers give it the temporary tag 11P L3Z and keep tracking it. But within days, and on July 1st and 2nd, when larger observatories in Chile aim their powerful lenses at it, something feels off. Its speed, far beyond the range of ordinary asteroids. Its trajectory, not following the familiar loops of objects bound by the sun's gravity. Meanwhile, amateur astronomer Sam Dean digs through earlier survey images and spots the same faint dot hiding in data from several days before the Atlas detection. That finding gives professionals extra measurements to nail down their path, and the result is clear. It's not from around here. Within a week, more than 100 observations from telescopes across the globe confirm the verdict. This is no ordinary space rock. It's an interstellar object, a traveler from beyond our solar system, destined to swing by once and vanish forever into deep space. They officially named it 3I/ATLAS. The 3I stands for the third interstellar object ever detected. The Atlas honors the survey that spotted it first. And here's the part making headlines. It's inbound, moving fast, and getting brighter as it approaches. Scientists now have only a short window to learn everything they can before it's gone for good.
The comet is expected to pass within 130 million miles of Earth on October 30th, 2025. This exploration of the unknown inspires us to push the boundaries of science and our collective understanding, fostering a spirit of inquiry even as it highlights our vulnerabilities.
But wait, this is where it gets mind-blowing. The first thing scientists notice is its speed. Roughly 132,000 miles per hour. That's fast enough to get from Earth to the Moon in about an hour and a half. Then there's its possible size. It could be up to 12 miles wide. That's 20 kilometers. To put that in perspective, Oumuamua and Borisov, our first two interstellar guests, were only a few hundred meters across. This thing could swallow them dozens of times over. Its brightness is another mystery. It reflects way more light than expected, meaning it's either covered in an unusually shiny material or it's truly massive. Both options make scientists raise their eyebrows. On top of that, there are early hints of comet-like activity, maybe a faint coma, the glowing cloud that forms when ice is vaporized in sunlight. If true, it could grow a spectacular tail near its closest approach to the sun, called perihelion, and its orbit, hyperbolic, an open curve that will fling it back into interstellar space once it swings by. Even stranger, it's slicing through the solar system at a steep angle, nowhere near the flat plane where most planets travel. This is the cosmic equivalent of a drive-by from a visitor who doesn't live in the neighborhood. Just to give this some context, back in 2017, we had our first confirmed interstellar visitor, Oumuamua, a long, cigar-shaped object that didn't move like any asteroid we'd ever tracked. Its odd acceleration, as if pushed by something other than gravity, puzzled astronomers. A few even floated the idea that it might be a fragment of alien technology, though no proof ever emerged. Then in 2019 came 2I/Borisov, unmistakably a comet. It released streams of gas and dust just like the icy wanderers in our own Oort cloud. But chemical studies revealed subtle differences. At roughly 400 meters across, it became the first interstellar comet we could watch in real time, giving scientists clues about the conditions in a completely different planetary system. Now in mid-2025, 3I/ATLAS takes its place in this small but growing list. Larger, moving faster, and likely brighter than either of its predecessors, it's giving us something we've never had before. Months of advance notice before it reaches its closest point to Earth. Why does that matter? Because each of these objects is essentially a time capsule, a sample of raw material from another star system, preserved since its formation and unaltered by human contact. With only 2 previous examples, it was impossible to say whether interstellar visitors were rare, common, or wildly varied. Now, with 3 confirmed cases, patterns are starting to emerge, and so are the differences. Size, speed, brightness, and chemical activity vary greatly, suggesting immense diversity among the worlds beyond our sun. And with 3I/ATLAS heading our way with plenty of warning, astronomers have a rare chance to prepare and to capture the most detailed data yet from a visitor between the stars. Right now, in July 2025, this object is about 3.8 astronomical units from the sun, deep within the asteroid belt, silently cruising between the orbits of Mars and Jupiter. That's roughly 570 million kilometers away. Yet for astronomers, it's already close enough to track with incredible precision. On October 3, 2025, it will swing by Mars at its closest approach, giving the red planet a front-row seat to this cosmic visitor. This flyby could help refine its orbit and possibly reveal how its speed and direction change under the influence of gravity from nearby bodies. Just 3 weeks later, on October 23rd, it will reach perihelion, its nearest point to the sun, still about twice the Earth-Sun distance. That means it's not coming anywhere near Earth's orbit during this phase, but it will be at its brightest, making it a prime target for telescopes worldwide. Then in December 2025, it will make its closest approach to Earth, but close is relative here. The object will be on the opposite side of the sun, ensuring zero threat to our planet. Even so, its unique positioning means some observatories may catch it silhouetted against the sun's corona, a rare and scientifically rich opportunity. After that, the show's over. It will slingshot away from the sun's pull, accelerating into deep interstellar space, never to return. In other words, if we want answers, this is our only chance. This is the first large interstellar object we've ever detected early enough to study for months rather than days. In 2017, Oumuamua passed through before scientists even realized it existed. In 2019, Borisov was spotted just weeks before it left. This time, we have a head start, and that changes everything. For planetary scientists, this is like receiving a sample return mission from another star system without ever launching a spacecraft. The dust, ice, and gas it carries are remnants of an alien solar system, preserved for millions or even billions of years. Analyzing its chemistry could tell us whether the ingredients for life are common across the galaxy or unique to our cosmic neighborhood. Instruments like the James Webb Space Telescope, JWST, will play a starring role, capturing infrared spectra to identify molecular signatures, things like water ice, complex organics, and exotic minerals never before seen in our system. Ground-based telescopes, radar arrays, and even amateur astronomers will join in, pooling data from multiple wavelengths to build a complete physical and chemical profile. And here's the kicker. If the object shows unusual behavior, like unexplained acceleration or strange emissions, we'll have the tools to catch it in the act. This could be the most revealing interstellar encounter humanity has ever witnessed. Despite all this planning, huge mysteries remain. First up, what is this thing? Its reflectivity and shape don't quite match a typical comet or asteroid. Some astronomers wonder if we might be looking at a new category of interstellar body altogether. Its brightness fluctuations are another puzzle. Is it simply large and shiny, or small with a highly reflective surface? If it's the latter, what's causing that unusual sheen? Metal-rich minerals, frozen exotic gases, or something entirely unfamiliar? Then there's its rotation. Data so far suggests it may be tumoring chaotically, possibly the result of an ancient impact. That could expose fresh material from beneath its surface, giving scientists an even better look at its interior composition. Its age and origin are equally mysterious. Tracing its path backward could, in theory, lead us to the star system it came from. But interstellar travel is messy. After millions or billions of years wandering the galaxy, pinpointing its birthplace is like finding a single grain of sand on an entire beach. And finally, will it exhibit non-gravitational acceleration like Oumuamua did? That would mean something besides gravity is affecting its motion, possibly outgassing from volatile ices, or, more intriguingly, an artificial propulsion system. While no one is jumping to conclusions, the scientific community isn't ruling out any possibility until the data is in. Harvard astronomer Avi Loeb has already made headlines for suggesting that 2017's Oumuamua might have been an alien probe. Now, with 3I/ATLAS, he's urging the scientific community to keep an open mind. While the leading explanation remains natural, a comet-like object from another star system, Loeb says it's worth checking for artificial origins. What would tip the balance towards something engineered? First, unexplained course changes that can't be explained by gravity or simple outgassing. A subtle but sustained acceleration, like Oumuamua showed, would be a major clue. Second, constant brightness, no matter the rotation angle, could suggest a flat, engineered shape, something nature rarely produces. Third, radio emissions or chemical signatures that don't match known space materials would be a game changer. For now, there's no evidence of any of these. History has a cautionary tale. The first pulsars were nicknamed LGM, Little Green Men, because their regular signals seemed artificial. Within months, scientists realized they were natural neutron stars. The lesson: extraordinary claims demand extraordinary evidence. But the search is still worth it. If 3I/ATLAS turns out to be just another comet, we'll still learn a lot about alien star systems. And if it's not, well, then humanity will have faced the most profound discovery in history. The tracking of 3I/ATLAS is a global operation. Ground-based telescopes in Hawaii, Chile, and South Africa are locked onto its trajectory, measuring its speed, brightness changes, and spectral fingerprints. These readings reveal not just its path, but also what it's made of. In space, the James Webb Space Telescope is poised to scan it in infrared, capable of detecting faint chemical and mineral signatures in its dust and ice. The Hubble Space Telescope will focus on ultraviolet light, revealing details about its composition that Earth-based observatories simply can't see. Meanwhile, radio telescopes like Green Bank and Meerkat are listening, not for alien messages directly, but for radio emissions generated by its interaction with the solar wind. This can tell scientists about the object's plasma environment, magnetic field, and even surface activity. As it approaches perihelion on October 23, 2025, astronomers expect its brightness to spike, possibly sprouting a visible tail like a comet. Every flare of gas or dust will be logged, analyzed, and compared to both solar system comets and past interstellar visitors. The coordination is remarkable. Never before has humanity been able to mount such a rapid, multi-platform campaign on a newly discovered interstellar object. Whether it's natural or artificial, 3I/ATLAS is under the closest watch in astronomical history. Before 2017, no one had ever confirmed an interstellar visitor passing through our solar system. In the past decade, we've seen Oumuamua in 2017, Borisov in 2019, and now 3I/ATLAS in 2025. This sudden burst doesn't mean these objects are rare. It means we've only just gotten good enough to see them. The next big leap will come from the Vera Rubin Observatory in Chile, set to begin its all-sky survey soon. Experts predict it could find several interstellar objects each year. Why does that matter? Because it opens the door for rapid response missions. Imagine detecting an interstellar object early enough to launch a probe, intercept it, and analyze it up close before it leaves forever. NASA and ESA scientists are already sketching concepts for spacecraft that could wait in ready orbit, able to slingshot toward the next cosmic visitor at short notice. Beyond the tech, there's a philosophical shift. For centuries, we saw our solar system as an isolated bubble. Now we know it's part of a galactic ecosystem, trading rocks, ice, and dust with countless other systems. Some of those bits might carry the building blocks of life, or evidence of civilizations far older than ours. With 3I/ATLAS, we're not just studying a rock, we're looking at a messenger from a place we may never visit, holding secrets billions of years old. And in the coming years, such encounters might become routine, each one a postcard from the wider galaxy. Whether 3I/ATLAS is a natural giant or something far stranger, it's a reminder that our solar system is not alone. Somewhere out there, other worlds exist, and sometimes they send visitors our way. The question is, what stories will the next one tell?